Gurubhyo Namaha. Pranamams to all the learned people gathered here. It's such an honor to be here in the presence of all of you. I've been listening to all of you speak, and it's been such a mind-blowing experience. I'm reminded of the words of the great sage Tyagaraja Swami, who composed in my mother tongue of Telugu. And I think it's an apt way of greeting this audience. Endaro Mahanubhavalu, Andariki na Vandanamulu. So today I want to talk to you about quantum physics and Vedanta from the perspective of both a quantum physicist, an engineer who's a quantum physicist by choice, and from a perspective of a Vedantin. So let me begin with the most controversial statement here. The Nobel Prize for Physics was awarded in 2022 for scientists who proved that the universe is not real. Let me repeat it again, scientists who proved that the universe is not real. And generally when you look at this statement, everybody tends to assume that this has, some Vedantin came up with this statement. They appropriated quantum physics and decided that it will fit into Vedanta. But I'm here to tell you that this is not a statement given by a Vedantin. This is what all Western scientists who have no connection to Vedanta are saying. See, this is an article which came out in Scientific American, which is a leading science publication in US when the Nobel Prize was announced. And this is what it said. The universe is not locally real, and the physics Nobel Prize winners proved it. I'm not going to discuss locality because it's been extensively discussed yesterday. But basically, for all intents and purpose, universe has been proven to be not real. And science nerds and science enthusiasts are discussing it with a lot of excitement all over the internet, and none of them are talking about Vedanta. In fact, most of them who are discussing this are Westerners. I'm telling you this because you should not be on in the misconception that this has somehow been invented by some Vedanta student. So now if you look at quantum physics, the two fundamental principles of quantum physics align with two fundamental principles of Advaita Vedanta. First, quantum physics says that universe is not real, and Advaita has always been saying universe is mithya. It's not satyam, it is maya. So those two principles align. More importantly, there is a second principle in quantum physics. It is the observer who brings particles into existence. It is observer who brings reality into existence. And this is what Vedanta says. The Brahman, the consciousness principle which brings the universe into existence, is only a Sakshi. That is why Brahman is called Sakshi Chaitanyam. That's why you say Brahman is Akarta Abhokta. So you can see the two fundamental, that's why quantum physics and Vedanta are discussed in the same breath. Two fundamental principles of quantum physics and two fundamental principles of Advaita Vedanta overlap very well. And whether they mean the same thing or not, I will discuss as we go through this presentation. So what I want to do in this presentation is two things. First, I want to take you through a short journey through physics to show you how it has reached this point where it's converging with one of the most ancient schools of knowledge. And second, more importantly, while this is a matter of pride for us, and most of you here will agree that Vedanta doesn't require validation from science. That's not what we are seeking. But Vedanta is a science of consciousness, and for thousands of years, brilliant minds have added to this knowledge base. And its knowledge base can help solve open questions in quantum physics. So I'm going to take you through one such open question and solve it by applying the principles of Advaita Vedanta. So first, let's go on a short journey through physics. First, in classical physics, in the Newtonian view of physics, consciousness had no place. Universe was made up of matter, and there were a set of laws, and the interaction of matter and laws gave birth to the universe. Everything about the universe can be explained by using these laws and its interaction with matter. So there was no place for consciousness, be it God who runs the world, or be it us insignificant human beings. This view was shattered by quantum physics. quantum physics brought the conscious observer to the very center of reality. It became clear that observer was central to shaping reality. And in order to understand this, we need to look at the double-slit experiment. Now, every person who spoke about quantum physics had this image, if you remember. This is a very defining experiment in quantum physics. It is one of the first and still continues to be the most important experiment in quantum physics, because it is this experiment that revealed how weird our world is. And it is what started with this experiment led to the proof that the universe is not real. So it's important that we understand this experiment. Again, with my respect to the mathematicians who spoke before me, this is an engineer's perspective. You know, mathematicians are interested in abstract concepts, but engineers are interested in how things work. So I'm going to tell you how this experiment worked. And with this, you will understand why observer is central to reality. You know, observer is one of those things in quantum physics. It's like the elephant in the room. Everybody sees it, but nobody wants to acknowledge it. So in this presentation, I want to acknowledge the observer. So this is how the experiment is set up, okay? So you have an electron gun on one side. On the left-hand side, you have an electron gun which shoots a beam of electrons onto the central screen. The central screen has two small openings. These are called double slits, and that's how this experiment gets its name. On the other end, you have a screen, which is a detector. So every time an electron hits the screen, it will leave a mark on this screen. So when you shoot a beam of electrons, you will know where it hit, how it passed through the double slits and hit the screen. So let us first begin with what was expected. So electrons are just small, tiny particles, right? You can think of them as tiny balls. So they are traveling towards the double slit. So what would happen? How would the electrons, tiny balls, travel through this double slit? When they hit the screen anywhere, they will bounce off the screen. The only place where they can cross through to the other side is through the double slits, those two openings. So once they go through the openings, what will happen? They will hit the screen exactly parallel to the slits. You understand this? This is how you would expect the experiment to work. There will be two parallel lines, two parallel bands, which are parallel to the two slits in the middle. That's how it will be. They expected the experiment to look. But instead, they saw this pattern. This is the signature pattern of quantum physics. So it's a series of bands spread across the length of the screen. The scientists were shocked by this because if a set of particles were traveling towards the screen, then this is not the image that will appear on the screen. But there is one time when this type of image will appear on the screen. When two waves interact with each other, you get this pattern. It's called the interference pattern. So let me explain this with an example. Let's say you have a still pond of water and you drop a pebble inside the water. What will happen? You'll see a series of concentric circles emanating from the center, right? This is a wave which is propagating through the surface of the water. So let's say you have two waves. You have dropped two pebbles and there are two waves on the surface of the water and they collide with each other. When two waves collide, they form a distinct pattern. And this pattern is called the interference pattern. And a cross-section of this pattern is what we see on the screen, what you see in the double-slit experiment. So now this befuddled the scientists. How can a particle and wave be the same? How can a particle behave like a wave? Particle is a small object located in space with a specific charge and specific momentum. A wave is spread out in space, it is ephemeral. It has totally different look and feel. So how can a wave and particle be the same? How can a particle exhibit a wave behavior? So let us see what is happening. Like based on the results of the experiment, this is how you should imagine how the particle is behaving. When you are sending a particle, it's not a particle which is going towards the double slits. Instead, one of those pebbles you have dropped and a wave is propagating towards the double slit. You see those circles there? And what happens when a wave hits the double slit? Because wave is spread out in space, it will enter both the slits. You understand the difference? If it's a particle, it can only enter one slit. Either one of the slit only it can enter. But because it is a wave, it is entering both the slits. So when it enters both the slits, it comes out as two waves from two slits. And these two waves interfere with each other, and that's what you see as the interference pattern on the screen. Here's a small video to show you how this happens. So an electron is propagating like a wave. It hits the double slits. Then through the double slits, it emerges as two waves. It creates the interference pattern, and when it hits the screen, it looks like this. This is the pattern that is appearing on the screen. Now, the scientists were very confused. You know the main action is happening at the double slits. At the double slits, if the particle was going only through one of the slits, you will not see interference pattern. If a wave is going through both slits, you will see the interference pattern. So they decided to keep a detector in front of the double slits. They decided to keep a detector. A detector is nothing but a camera which takes a picture of the particle. So whichever slit the particle passes through, the camera will detect it. So that is the purpose of the detector. What do you think happened when they kept a detector? They saw two parallel lines on the screen. They didn't see the interference pattern. It was as if only particles were traveling through the slits and not waves. So when you keep a detector, when you keep a camera, a particle is behaving like a particle. When you don't keep the detector, it is behaving like a wave. So after extensive analysis of this experiment, the founders of quantum physics like Niels Bohr and Werner Heisenberg came to this conclusion, that a particle does not have any real existence until it is observed. Until you make an observation, a particle does not exist at all. This is what Niels Bohr and Heisenberg said. It's called Copenhagen Interpretation of quantum physics. Now, the question arises, who is the observer here? Who is the observer? The scientist who is keeping the detector in front of the double slit, or the equipment which is detecting the particle? What is your answer to this question? Who you think is the observer? If you see, the scientist has no role in this experiment, right? He's just keeping the detector and moving away. The only thing that is interacting with the particle is the detector. So you would assume that it is the detector which is causing the collapse of the wave function. It is the detector which is causing the particles to appear and not the scientist. So this was the initial conclusion of physicists. They said, observer means anything which can detect a particle, any inanimate thing which can detect the particle. Then what happened? There were several experiments conducted to see if this is really the case, to see if it is the detector that is causing the collapse of the wave function. I'm going to explain a few experiments here. I know this is a bit heavy, but if you want to know, if you really want to understand the significance of observer, it is important that you understand how this experiment works. It is just amazing the impact of observer when you watch these experiments. So let me tell you, or give you a few examples. This is a schematic representation of a complex experiment, but a few different versions of double slit experiment, all of which suggest that it is the conscious observer and not the detector that is causing the particle to come into existence. So in this version, what they did, in the next version of the experiment, they put the detector after the double slits, behind the double slits. This is called the delayed choice experiment. Now you may ask, what difference does it make? Now you see, when the particles hit the double slit, when they go to the double slit, they have to be traveling as waves because there is no detector to interfere with them. They should travel as waves and emerge from both the slits. That's how it should work, right? Because now the detector is not there before the double slits. When the detector was there before the double slits, they were first interacting with the detector, becoming particles, and then entering the double slits. Now it's the other way around. They are entering the double slits, and after that, you have the detector. So they expected to see the interference pattern. But what did they see? They saw only two lines two lines, which will, if particles behave like particles and not waves, you will see those two lines. Now you just understand the implication of this experiment. What it means is the particle knows even before it's entering the double slit that there is somebody who's going to observe them after they pass through. So in retrospect, it is changing its behavior and behaving like particles. You can understand? You can see what it's doing? If this is blowing your mind, let me tell you another example, another version of this experiment. This is called quantum eraser experiment. In this, what happens? You keep the detector where you are always keeping, either in the front or back of the double slits. But you erase the information from the detector before a conscious observer, before a scientist can read the detector. So you are erasing the information before a scientist can know, look at the detector and know where the particle is. What do you think happened in this version? Waves. You just imagine, the particle seems to know that although this detector is detecting me, looking at me, a conscious observer will not be able to see me. So I can behave like waves. So from this you can see it is not the detector that is causing the collapse of the wave function. It is the conscious observer. Okay, I want to tell you two more versions of the experiment because this is, you can see the power of the observer in these experiments. Many people spoke about entangled particles, right? Entangled particles, I was extensively discussed yesterday. They are like twins, mirror images of each other. So one advantage with entangled particles is you can look at one particle and infer what the other particle does. Professor Ravi also spoke about it yesterday. By looking at one particle, you will be able to determine the location, position, and properties of the other particle. So they used entangled particles to do the double slit experiment. So how did they do it? You create a pair of entangled particles. One pair you send it through the double slits, and the other pair you use the detector. You are placing the detector and looking at the other pair of the twin. Red is one part of the twin, green is the other pair of the twin in entangled particles. You are looking only at the green particles. So the red particles, when they are going through the double slits, there is no detector at all. There is absolutely nothing which will interfere with them. Yet, what happens? You see only two lines. Again, I want to tell you from the mind of the particle. I'm using it in quotes because particles are not thinking entities, but just for the purpose of understanding, the red particle seems to know that somebody is watching its twin, and they will be able to figure out where they are. They'll be able to figure out their location. So it is it is becoming a particle even though there is no detector in its path. Okay, one final version of the experiment I want to show you. This is called the delayed choice. This is another version of delayed choice experiment. So here what you do, you look at the twin not while the double slit experiment is happening. You are passing the red particle through the slits, and after it completes its entire journey and hits the screen, you look at the green particle. So when the experiment is in progress, the red particles are not being observed, nor its twin is being observed. Yet, what happens? You get two lines. Particles seem to know that in the future somebody will be looking at that twin, so I will behave like a particle. So this is how important an observer is in quantum physics. Now, based on all these experiments, what we can conclude, it is not the inanimate detector that is causing the particles to arise. It is the conscious observer whose presence is mandatory for the particles to come into existence. And we have also seen that it doesn't matter whether the conscious observer is observing now, even in the future or anywhere else in the space he observes, as long as he has the intent and the capacity to observe the particle knows and no longer behaves like waves. And you also notice that the influence of observer transcends space and time. It doesn't matter where you keep the camera, or it doesn't matter how far into the future you're going to observe the particle. The particle still knows. So this is the power of observer in quantum physics. And this is called observer effect. So if particles don't exist when nobody is observing them, then the whole universe is made up of particles. So nothing exists until it is observed. This is the observer effect of quantum physics. Now we will come to the definition of reality. I said the Nobel Prize winners proved that the universe is not real. So we'll see what reality means in physics. Yesterday, I think Satish Bhattji gave a beautiful, brilliant exposition on what reality means for Advaita Vedanta. So physics also has a clear definition of when you can call something real. And it's much simpler than Vedanta. It says, and for anything to be real, it has to have objective and independent existence. These two properties it should have. So what do we mean by that? Let's say I'm looking at all of you. I'm standing here and looking at all of you. If I ask the question, are you real? Are you real? Do you really exist? Physics has an answer for that question. It says, you are real. You are real because even when I'm not looking, if I turn away, you will continue to exist. Even when I'm not looking, you will continue to exist. And anybody who comes on the stage and looks at you will agree on what they are seeing. How many people are sitting, what color clothes they are wearing, everything they'll agree. So it has independent and objective existence. Now let's say I go to sleep tonight and I dream of this auditorium. I can exactly picture this. I see each one of you seated here. Is that real? Physics will say it's not real. I can ask why both are identical. I'm having the same experience. I can see you here, I can see you clearly in my dream too. But physics says it's not real because when I stop looking, that auditorium will cease to exist. And there is nobody else who can look at it and validate what I'm seeing. So it doesn't have an objective and independent existence. Now we saw the behavior of particles. Tell me which definition of reality does it adhere to between these two? Is it the auditorium which I'm seeing now, or is it the auditorium of my dream? So particles exist only when someone looks at it, when it's observed, and they cease to exist when nobody looks. So a particle has no real existence. It's not real. So this was the conclusion of quantum physics right from the beginning. This is what Niels Bohr said. Everything we call real is made up of things that cannot be regarded as real. If quantum physics hasn't profoundly shocked you, you haven't understood it yet. This is what Niels Bohr said. Now, I'm sure it has profoundly shocked many people, except if you're a Vedanta student. For everybody else, it will be profoundly shocking, this conclusion. And some of the most brilliant minds had problems with this conclusion of quantum physics. So what Einstein said, one of the strongest opponent of this Copenhagen interpretation of quantum physics was Einstein. He said, what are you saying? This sounds like rubbish. Do you say moon will not exist if nobody is looking at it? If particles don't exist when nobody is looking at it, moon is made up of all these particles. So when no one is looking at it, moon should not exist, isn't it? Is that what you're saying? At the same time, quantum physics could not be dismissed. We saw Nileshji also said, her strength of its theory is its ability to predict how well, to explain how the world works and how well it's able to predict future things which have not yet been discovered. And quantum physics was excellent at it. Yesterday, Dr. Ravi Shankar said, even at the level of galaxy, quantum physics works. So there is no doubt that quantum physics is a representation of reality. So what Einstein said is, quantum physics is not wrong, it is correct, but it is incomplete. He said quantum physics is incomplete. This is called hidden information hypothesis. So let me tell you, explain to you what he meant. Let's say you're watching a magic show. You're watching a magic show being performed here. So you're seeing this magician cutting somebody into two and putting him together, take out rabbits from his hat, all of which would defy the laws of nature. So why does it look like magic to you? Because there is something he is doing behind your back which you cannot see. There is some hidden information which he is having which you don't see. That is why it looks like magic to you. If he were to call you up on stage and explain to you how he is doing the trick, then you'll know there is nothing illogical about it. He's not really cutting people into two or really conjuring up people from his hat. There is this information, if you get to know, this magic will make perfect sense to you. So Einstein said that's how quantum physics is. There is only one part of it we are seeing. There is some missing information about the nature of particles which we have not yet understood. If we understand it, quantum physics will appear completely logical. It will make perfect sense. And for a long time, nobody could prove that information is not missing. We are not missing some information. Like in our pramanams, there is anupalabdhi, one pramanam, no absence. In science, absence is not a pramanam. You have to prove the absence also. So you don't have, this is, how can you prove that an information is not, we are not missing information? Then a brilliant scientist called John Bell came up with a theorem. Yesterday, several people, I think Mr. Vasudev, Dr. Vasudev Shyam, gave a brilliant exposition on Bell's theorem. He came up with a statistical theorem on how we can prove whether there is an information hidden or whether there is no missing information and quantum theory is perfectly right. He came up with a hypothesis. But although this hypothesis was in existence, it was very difficult to prove it because coming up with an experiment to check the Bell's hypothesis was very difficult until these scientists came along. Scientists who proved that the universe is not real. They come up with some brilliant mind-bending experiments to prove Bell's hypothesis. That is, their experiments proved that Bell's hypothesis was invalidated. And this is how they proved that there is no hidden information and particles do not exist until somebody observes them. I wish I could explain these experiments. They're really complex experiments, but I would strongly recommend that you go look it up because their sheer brilliance is astounding. And just to quip your interest, I want to give you one little fact about the experiment, the one which Anton Zeilinger did, the third physicist. You know, by this time it became clear that the intentions of the scientists were impacting the behavior of the particles. We saw it doesn't matter where you keep the detector, how far away you keep the detector. Only thing that changes the behavior of the particle is your intention and ability to measure the particle. Now you had to come up with an experiment where your intentions cannot interfere with it. How is it possible? How is it possible to set up an experiment without intending to measure? And Anton Zeilinger came up with a brilliant setup to overcome this difficulty. So I strongly suggest you look up this experiment. If you want references, after this talk, I will provide it to you. Now, quantum physics has proven that the world is not real. But although it's a very exciting proof, there are still it has raised more questions than answers. Would the moon exist when nobody is observing it? How can the unreal particle give rise to real world? And most importantly, the fundamental question in quantum physics is how is it that an observer is able to bring particles into existence? This is called the observer paradox. So I'm going to try answer this question using Advaita Vedanta. As I said, Advaita Vedanta is a science of consciousness, and if we apply the principles of Advaita Vedanta, many questions we can find answers to. And so one of the most important questions I want to try in my own way to answer using the principles of Advaita Vedanta. So let us delve little into Vedanta. So what does Vedanta say is real? If the whole world is mithya, the whole world is unreal, what is real? As Mr. I think Satish Bhatt, again he gave a beautiful logical explanation for this. Only reality is consciousness, Brahman. The whole universe with all its multiplicity is nothing but Brahman, the consciousness. Brahmaivahamidam jagatya sakalam chinmatra vistaritam, says Adi Shankaracharya. So there is a question, how can this world with all its multiplicity emerge from consciousness? How can it emerge from consciousness? So many analogies are given in Vedanta. Yesterday we saw several. We saw Rajju Sarpam, we saw pot and clay. Today I want to give you another famous analogy of Vedanta, that of a dream. So Vedanta compares the universe to a dream and Brahman to the dreamer, the person who is dreaming. And it is a very powerful analogy because it helps explain many relationships between Brahman and the Mithya Jagat. So there are some straightforward relationship. The entire dream, with all its multiplicity, exists within you. You create, sustain, and destroy your dream. And what is everything in your dream made up of? You may have stars, galaxies, chairs, beds, rocks, insects, anything you can dream up of, many different things. But what are they made up of? They're all made up of your consciousness. They are a projection of your consciousness. Although within the dream it doesn't seem like that, that is how it is. And this is true for Brahman also. All these relationships are true for Brahman. But today I want to delve into another subtle relationship which is important for us to resolve this observer paradox. What do you do to create your dream? Is it something like, do you plan, execute, build, do physical labor? No. You create your dream by simply witnessing it. The only reason the dream exists, the only reason the dream comes into existence is because you witness it. Now let me ask you a question. Can anything exist in your dream which you don't see? Think about it for a second. Can anything exist in your dream which you don't see? Actually, the question itself is wrong. Things get existence in your dream because you are seeing them. The only reason anything exists in your dream is because you are seeing it. What you don't see does not exist. What you don't see ceases to exist. So let's take an example. You're dreaming of the stars and galaxies and planets. Then next minute you're dreaming of a garden. So what happened to those stars? What happened to those planets? Are they tucked away somewhere so that you can go back and see them? No. Everything in the universe exists because Brahman witnesses it. And nothing which Brahman does not witness exists. So that is why Brahman is called Sakshi Chaitanya. So you can see the uncan parallels here. The observer brings the particle into existence by looking at it. Sakshi Chaitanya brings universe into existence by looking at it, by observing it, by being a Sakshi. However, this does not fully resolve our paradox. You may ask the question, okay, I'm a skeptic, I'm not a Vedantin. Even if I accept your view that there is an all-pervading consciousness from which this whole universe emerges, how can it explain a puny little human in a tiny little corner of the universe bringing particles into existence? They may look similar, but they are not the same, isn't it? For that, to resolve that, you should go to the highest teaching of Advaita Vedanta, the Mahavakyams. What do the Mahavakyam says? You are Brahman. This consciousness is Brahman. I am Brahman. Advaita Vedanta is very clear. It doesn't say you will become Brahman, or you are like Brahman, or you are part of Brahman. It says you are Brahman. There is an equal to sign there. So let us look at how we can resolve this. Go back to the example of our dream. So there are a lot of conscious entities in your dream. There are not just objects in your dream. There are conscious entities in your dream. How are they getting their consciousness? How are they able to experience the dream world? There's a person reading a book. There is a person watching the cell phone. All of them in your dream. How do they get their consciousness? They get it from you. But how? Have you divided your consciousness and given it to all the people in your dream? Like you take a cake and you divide it into multiple pieces. Each piece is distinct and separate. So they are not part of the whole. Is that how you have divided your consciousness? No. Let us take an example. Here is a person, let's say there's a person in your dream who is watching the sunrise. How is he getting this consciousness to observe the sunrise? It is you, the dreamer, who has created the sunrise, and it is you, the dreamer, who is experiencing the sunrise through his eyes. So the experience of every person in your dream is your experience. The experience of every conscious person in your dream is your experience. But you remain one undivided consciousness. And people in your dream may think, I am limited, I am small, I am part of this world. But their consciousness is that consciousness which created this whole dream. So you should, that is what we mean, that's what Mahavakyams are saying. You are Brahman, you are equal to Brahman. So you can never ask the question, how can a puny little being create a particle, bring particle into existence? It is because there is nothing puny about an individual. He is that consciousness which brought the entire universe into existence. So I feel Advaita Vedanta has potential to answer many unanswered questions and many paradoxes in quantum physics.
Any questions?
So I have a question, Dr. Suroni here. Ma'am, you mentioned that particles are mindless entities.
Yeah.
After going through this experience and this, the way they are able to predict the observer's behavior, do you still think that particles are mindless entities?
Okay, sir.
And because where does the mind begin and end?
Yeah.
Should it be a multicellular organism like a human being that has mind, or can particle also have a mind?
Yeah, see, that's the problem with quantum physics. You tend to look at it always from Bahya Drishti. Antarmukha Samaradhya doesn't come when you look at quantum physics, but we need to do it. See, one way of thinking of it is particles are coming into existence, thinking and coming into existence when you're looking at it. That's the way it appears, but that's not the way it is. Let's say I will upgrade to another analogy. I'm wearing a virtual reality glass. So everything seems to come into existence when I look at it. So there are buildings coming in. When I turn, the buildings disappear. So should I assume that the buildings are conscious? They're having a mind of their own and they appear because I'm looking at them? It is my specs that is lending existence to those buildings. If I remove these goggles, none of them will exist. So you should not look at it with Bahya Drishti. You should look at it Antardrishti. Imagine you are seeing everything, you are seeing a spot everywhere you look at. You can think that there is a spot moving everywhere I look at. The other thing you can assume is there is something on my specs. So everywhere I look at, I'm looking at the spot. So it is the observer that has to be looked into rather than the particles.
I had the same question.
Okay, I will first answer Swamiji's question. So he says, the question is, is cat or a dog conscious being? See, so the corollary of the question is, you're asking whether cat can be considered a conscious being to do the experiment. So both physics and Vedanta have two different answers to it. Physics or the modern science looks at consciousness as higher functions like decision making, thinking. So if you look at that definition of consciousness, only human beings are conscious, and it doesn't make sense to think that only a human being can bring a particle into existence. But you just look at Vedanta's definition of consciousness. It doesn't think of every living being is consciousness. And what do we mean by consciousness there? Simple awareness. The Sakshi Tattvam. What is Sakshi Tattvam? It's simple awareness. When you're in deep sleep, what do you see? What do you do? What do you hear? You're simply aware. And that awareness is all pervading. I think it transcends human beings, and cat, dog, bacteria, everything can be considered. Non-living beings, I'm not sure. I'm not sure about that.
My question is, cats, dogs, or other animals can also be trained to observe.
Yes.
So, whether any such experiment was done that, other than human beings, some other animal has tried to observe, and did it have any effect on the double-slit experiment? Number one. Number two, now artificial intelligence, even robots can observe. They are not living beings at all. So when robots observed, whether they may decide to observe, they may not decide to observe. So based on that, were there any
okay,
results?
Let me answer both the questions. First question is about cats and dogs. Again, as that I think I answered it previously. Consciousness has two different perspectives from a physics and Vedantic perspective. You will have to decide on what you want to think of as consciousness. Regarding the second question about AI, see here you take the double-slit experiment. The detector is not a conscious entity, but it is able to bring the particle into existence. Why? Because a conscious observer is looking at it. I think you will have to extrapolate it to AI. AI can give you a lot of answers, but it is not a conscious entity. You should think of a robo as an evolved detector, that's all. A non-conscious entity which is more evolved and can do higher functions. Yeah. Yes, sir.
So what they had done something very similar, because the question of free will comes into this. So they brought in another person who is with the detector. So something similar was done, and the results were quite intriguing.
Okay.
Yeah. Have you seen David Bohm and von Neumann's work, integrated information theory, which is like it takes. See, from a detector, you have to come to the person.
Yeah.
And have you seen that work?
No, I have not. I don't recall it. I might have seen, but I don't recall now. Doesn't mean that we have to do, just because quantum physics and Vedanta is aligning, we cannot underestimate what science has achieved. You know, Vedanta says Vedanta said you can never know Brahman. Brahman is beyond experience. And now quantum physics is looking like it can come close to it. So I think both subjects have value to add to each other. I think quantum physics with Vedanta with its incredible knowledge on consciousness can add value to quantum physics. At the same time, the mathematical rigor and the experimental power of quantum physics can move Vedanta to the realm of science. It can truly be recognized as a realm of consciousness. So we should never look down on science just because I think it is not right to look down on science. That is what I believe.